34.2 Standard enthalpy change of combustion. In this chapter, we're going to cover three types of reactions. First, we can cover the combustion one. So first of all, in the last video, we mentioned about standard enthalpy change of reaction. The class practice that we have done is 34.1, like this one. You can see that, we'll have ethanol burn in oxygen and then give out carbon dioxide and water. So in the process, you will see that you have like negative 1,371. That means it's releasing 1,371 kilojoule per unit mole. Some of you may wonder, per mole, actually which reactant or which product we are talking about per mole. So in this case, we say that this is a standard enthalpy change of reaction. It is any kind of reactions that must have a enthalpy change in the reactions. So this one, we can see that this is a combustion. It happens to be a combustion, but actually it works for any kind of reactions. This value is just describing this reaction. If you have 1 mole react with 3 mole of oxygen and give out this number of mole product, then if you do this way, you will have like 1,371 kilojoule. And this per mole, actually it doesn't specify any one of the reactant, but we'll refer this per mole. We're talking about the chemicals in it that have one coefficient. One as a coefficient. For example, in this case, we'll have this one. The ethanol. The ethanol, you will see that we have one coefficient. That means per mole, then we're referring to this one. So if you have like 2 mole, then we have negative 1,371 times 2 times. So this kind of reactions we have no, first of all, you'll find out we have no specific targets. We didn't say which one will be the target of this equation. And also we follow the equation with the same coefficient. That means we'll follow this coefficient. So if you see per mole, you want to really know that which one chemical you're talking about. Normally referring to the chemical with one coefficient. In this case, that will be this one. So that will be the standard enthalpy change of reactions. But in the following, we will talk about the combustion and neutralization. Then we do have a target. So let's have a look. What is it? So first of all, standard enthalpy change of combustion. So when we talk about combustion, you'll see that we got a C, at the back. So we got a small C, at the bottom right corner, and then we have like a delta here. Delta means change, we just like identified what these things means. This small delta means change. H means enthalpy, and then we have a fine right there. This symbol we got fine. So we have this one represents standard condition. And then finally, our main character here, that will be C. C stands for combustion. So basically, when you look at a symbol like this, you will know that, that means standard enthalpy change of combustion. So this symbol means that. Normally when we talk about combustion, we have a target. What chemical we're going to combust this time? What chemical we're going to burn this time? So when we have a target, say like this way, we are going to burn methanol. Remember we have to show the state as well. So we have talk about a combustion of methanol. So for this one, because it is a target, so the target, when we write in the thermochemical equation for this one, your task, is to, when I give you a symbol like this, then you're going to write the equation at the back. So you're going to write the equation, this one here, thermochemical equation. So when we have CH3OH as the target, then this, we're going to put it into a combustion equation. Combustion, you know that, we're going to burn it. So we need oxygen. So you'll find it, in the equations, we'll burn this one in oxygen. And because we have carbon and hydrogen in it, so therefore you have carbon dioxide and water as a product. And then at the end, we also need to show the enthalpy change in the process. So right now, the per mole here, it got a meaning. So this per mole, actually, we're referring to the CH3OH. CH3OH. So that means each of the CH3OH, when we burn it, they will release 715 kilojoule. So your task, for these sections, number one, okay, you need to memorize the definition. Always will be asked, okay, in the public exam, you have like course 1 mark. So enthalpy change of combustion of a substance, what does it mean? Okay, the definition will compose of 3 parts. The first part, okay, we were saying that when it is an enthalpy change, okay, because standard enthalpy change, right? It is an enthalpy change. Okay, the second part will be when 1 mole of substance is burned in oxygen. This will be in echo to the word combustion. Okay, there will be in echo to the word combustion here. Okay, and the third thing is, okay, is a standard enthalpy change. So therefore, under standard condition. So when you do the definitions, okay, remember 3 parts. It is an enthalpy change. Okay, second part, when 1 mole of substance is burned in oxygen, it echoes the combustion words. And third part will be under standard condition. Okay, so that would be the definition for standard enthalpy change. So remember, okay, you need to spend some time to memorize this definition. Okay, this definition is very important. Okay, so the features for this standard enthalpy change of combustion, so we got 2 features. Number 1, okay, the coefficient of the substance, okay, to be burned must be 1. That one, okay, must be 1. What is by must be 1? Okay, you can see here. This one, it have to be 1. Okay, so you can't do the balancing, okay, and make this one. If you happen to be 2, okay, in the coefficient, then overall equation you have to divide it by 2, okay, to make it back to 1. Okay, so this one is very important. Second one, okay, you can see it in this table. You'll find that all the enthalpy change right there, all the enthalpy change here, all of them, they will have negative in front of it, because you'll find that combustion, it must be heat releasing, so it must be an exothermic reaction. So remember the features for standard enthalpy change of combustion, it must be a negative. So these 2 features is very important. These 2 features is very important. So remember, target must be 1, okay, and second one, the values, okay, it must be negative. Okay, so if we draw in an enthalpy level diagram, you'll find that when we have the reactant here, they form carbon dioxide and water. Okay, they must be going down. Okay, so therefore, a small value minus large values, okay, the product, small p minus large r, so the result must be negative. So it must be an exothermic reaction. Okay, so let's have first practice. Okay, so write thermochemical equation for the following substance. We have a lot of here. Okay, we'll just pick a few of them. For example, okay, let's do H2. Let's do butane, and then we can do a ethanol. Okay, so the equation basically you have like H2, you burn it in oxygen. Normally, when you do this one, okay, you do things like this. Is that right? But remember, when we write a enthalpy change of combustions of hydrogen, okay, this have to be 1. So if you write like this way, this one is wrong. So you have to overall divide the whole things by 2, and you have equation like this. Okay, you turn this one to gas. This one is gas state, and this one is gas state, and then the delta H C equals to negative 285.8 kilojoule per mole. So this is what you need to write, okay, for a thermochemical equation. So for the second one, okay, butane, okay, that will be C4H10 plus O2 give 4 CO2 and also H2O. We got 5 of them. So right there, okay, we'll have like 8 plus 5, we'll have 13 oxygen. Remember, don't multiply the whole things by 2, because we have to keep this one by 1 and keep this one by 1. This is the target, okay? So the target one, okay, must have 1 coefficient only, okay? So to end up this equations, okay, you remember to write the energy release in the process, okay? So the last one is ethanol. So you have like C2H5OH for this, and you're going to add oxygen, and you have like 2 CO2, and then you have like 3 H2O. In total, on the right hand side, you have like how many? 4 plus 3. You have 7 O2. okay, 7 oxygen there, okay, so you minus 1 of the oxygen here, so this one will be 3, okay. So do remember ethanol, you have 1 oxygen here. So this one is okay, because you have 1 right there, okay. You keep the target, okay, to have 1 coefficient, so therefore you don't need to or do any division or things like that, okay. Just add back, okay, the enthalpy change of combustion's value, okay. Remember, all of them will be negative here. Get it? Oh. So summary, you have to remember the definitions of the standard enthalpy change of combustion. Remember the definition made up of 3 parts: enthalpy change when 1 mole, enthalpy change when 1 mole of substance is burned in oxygen, okay, and under standard condition. Okay, 3 words. Okay, I think this word, okay, you have to add the word standard in front of it. Okay, so therefore we'll echo the third statement. So on the definition, bear in mind, okay, we'll have 1 mark on this. Second one, remember the coefficient of the substance to be burned, okay, always have to be 1, okay, and it have to be negative. Okay, this one must be 1. So example, just now we have mentioned, if you write this equation, you write like this way, it's wrong because this one is 2, okay, so you have to put this one by half O2 and you have a correct standard enthalpy change of combustion equation. Okay, so that's all for this video. Bye bye.